rule then. Well, there's two rules, the sine rule and the cosine rule. We'll look at the sine rule first. That's probably the easiest to use. So if you can use either rule, use the sine rule because that's easier, I would suggest. It's up to you. It applies to all triangles, but particularly it's used when there's no right angle. So it's used to find the missing side of the angle. There's a convention around how we label it. Right. So if we draw a triangle, we'll try and make it so that there are no obvious right angles, or that looks fairly close to a right angle at the top, but the idea is there's no right angles in it. And then we label the sides, A, B, C, and we use capital letters to represent the angles. So this is angle A, and that little hat above the letter signifies angle. Angle A, angle B, angle C. If you use that convention to represent the angles, and it doesn't have to be A, B, C, it could be D, E, F, it could be X, Y, Z, okay, any symbol. If I've used capital A to represent this angle though, then we call it side opposite A. So that's fixed. If I've decided I'm going to call this angle A, this is automatically side A, and we use the lowercase letters to represent the side. So that means this is side B, because it's opposite angle B, and this is side C, because it's opposite side angle C rather. Okay? So that's the convention we use when labeling these things. And then the sine rule says the ratio, the ratio of side A to the sine, hence the name sine rule, of the angle opposite side A. So the ratio of a side to the sine of the angle opposite it is always the same in a triangle. So in other words, that's the same as the ratio of side B over the sine of angle B. And that's also equal to the ratio of side C to the sine of angle C. Those ratios are always the same. And that is the sine rule. The sine rule. And I never know whether to put an E on the sine or not. Sometimes I don't. So, we use this rule if we know one of the ratios. If we know a ratio, we can use the rule. And that's the acid test. If we know one ratio and another value, i.e. another angle or another side, one other value, we can use the sine rule. So that's like a test. Because there's two rules, there's a cosine rule as well. So if we want to know which rule we're going to use in a situation, that's what we ask ourselves. If you know a ratio and you've got one other thing, then you can use the sine rule to find all the missing angles and all the missing sines. So in this example, let's try and find the missing sides and the missing angles in here. First question. Can we use the sine rule? Do we know one ratio and one other piece of information? Right. What ratio do we know? Right, we know this angle and this side. So what do I mean by ratio? I mean, do I know one side and the angle opposite it? And then if I do, I know one ratio. And have I got another piece of information? Yes. So using the sine rule, we can find this angle that's opposite the side we know. And then once we've got that angle, then I know two of the angles, so I can find the third, because all the angles in a triangle are 180. Once I've got that angle, I can find this missing side. So let's label this thing up, and then we can explain that. Plan to do this. We know one ratio, that's this one, and one other thing, this side, so we can find the angle opposite using the sine rule. So first find the angle A using the sine rule. Once we've got that, we can find angle C because all the angles in the triangle add up to 180. And once we've got that, we can find side C using the sine rule because we know the angle opposite it. Okay, so that's the plan. All we've got to do now is carry out the plan. So, angle A. We write down the ratio. We write down the sine rule. Let's look back at the sine rule. We don't need to write all three ratios. The sine rule just says these ratios, A over sine A, B over sine B, C over sine C, they're all the same. So we only ever use two of them. So we write down the ratio we know and the ratio that includes what we want to find. So let's apply that to this. In other words, we say, right, we know that 3.8, we know that ratio is 3.8 over sine 60. So 3.8 over sine 60, that's the ratio we know, equals 4.2 over sine A, which is what we're trying to find, angle A. Looking at the sine rule, this ratio of side A to sine angle A is the same as B over sine B and so on. I could just as easily have written these ratios the other way up. So in other words, the ratio of sine A over side A is the same as the ratio of sine B over B and so on. So I could have written these upside down and they would still be true. And I'm going to turn it upside down here because I think I want to find is underneath. So I go back to my problem now and I say, okay, look, what I'm after is this, and that's on the bottom. So flip that, and then flip the other side. So therefore, sine 60 over 3.8 equals sine A over 4.2. So now I've got what I want to find on the top. So you just write the ratio. Actually, you might decide to just go to this straight away, this line, write it that way up, because that's what we want to find. Now we've got to do a little bit of a manipulation, like a formula. Sine A is divided by 4.2, so I want to get rid of the 4.2, so multiply. So therefore, sine A, which is what we're after, equals this ratio, sine 60 over 3.8 multiplied by 4.2. Now I could at this point work it out, but the calculator will allow us to do it in one hit. So if the sine of A is that, then A is the inverse sine, like the inverse tan. The angle whose sine is sine 60 over 3.8 times 4.2. Now I can put that into the calculator in one hit and get the angle A. To get 73 degrees. Angle A is 73 degrees. So we've done part one of our plan. We found angle A. So now we can go to the second part of the plan and find angle C. So therefore, angle C equals 180 degrees, which is the whole triangle, minus the angle we know, which is 60 plus 73, the angle we just found. So what does angle C equal? Not exactly, is it? 47 degrees, thank you. So we now know angle C. So finally we've got to find side C. So little c over sine of 47 equals, and I'd always use the ratio we give at the start. We could have used the one we just found, but use 3.8 over sine 60. So we write down the ratio we know and the ratio that involves what we want to find. Now we want C, so we multiply both sides by sine 47 to get rid of it. So C equals 3.8 over sine 60 multiplied by sine 47. So now side C equals 3.2. And we've done it. We've completed. So what do we do? Typical problem here. We want to find the missing sides and missing angles, Matthew. Let Jack focus in on this little bit, please. So, what do? We've got to plan our approach, and that involves knowing the sine rule. So in the first place, we can only apply the sine rule if we know one of the ratios. We do in this case. So I can use the sine rule. So the first thing, the only thing I can find to start off with, is the missing thing opposite what we know, which is that. So I've got no choice other than to find this missing angle first. Once I've got that, then I can find angle C, because angle is 180. Once I've got that, I can use that angle C to find the missing side C. So you've got to go through it in the right order, okay, to do it. Right, we'll take a break then.